today we will study what is internal resistance of a cell, electromotive force, and then the terminal potential difference in this video. Okay, the first one is what is internal resistance of a cell. In simple term, internal resistance of a cell means the resistance of the cell. Cells is represented by this minus plus, so it will also have its own internal resistance, and the internal resistance is represented by small r. Okay, when a cell is connected in a circuit, it drives the charge in the circuit, right? So the rate of flow of charge is called current. So when the current flow through the cell, its electrolyte offer resistance to the flow of current. It is because of the fact that ions have to move against the background of other ions and the neutral or atoms. So the resistance offered by this electrolyte of the cell when the electric current flow through it is called its internal resistance. In a cell, suppose this is the electrolyte, anode, cathode is there, so this is the cell and we represent it like this, so the electrolyte, this is electrolyte. Okay, so the resistance offered by this electrolyte is called internal resistance. For a very freshly prepared cell, the value of internal resistance is very low, but as the cell is put to more and more use, its internal resistance goes on increasing. And next is electromotive force. Electromotive, the potential difference between the two poles of the cell in an open circuit when no current is drawn from the cell is called the electromotive force. Okay, let's explain with circuit. If battery, okay, this is external resistance, this is a cell. Okay, cell, so it will also have some internal resistance. This is key. Okay, see the potential difference between the two poles of the cell in an open circuit. In an open circuit means when the open means this key is open. Okay, in an open circuit means switch off, in switch off position, then the potential difference when cell means it is not on, that means we are not using this cell, So at that time, what is the potential difference between the two poles? This pole, negative, positive. There is a potential difference, right? Without potential difference, which the current cannot flow. So in a cell, there is always potential difference. So when the cell is not used at that time, what is the potential difference? That potential difference is called electromotive force. Okay. Next is terminal potential difference of a cell. So this, again, let's draw a cell. Put some resistance or external. The cell is also have its own internal resistance. Okay, this is key. Again, this is key. So when the key is not closed, that means it is switched. When when key is off, switch off, then the potential difference between the pole of the cell is called what? Electromotive force, EMF. Okay. And when the switch is on, okay, when the switch is on, what is the potential difference between the pole? It is called terminal potential difference of a cell. Okay. Terminal potential difference of cell. Electromotive force means when the cell is not in use, it is switch off position. When the cell is in switch off position, what is the potential difference? It is called EMF. Whereas terminal potential difference of a cell means when the cell is switched on, so this should be on. Okay. When it is on, what is the potential difference? What is the potential difference we are getting? So we have to check with using voltmeter. Voltmeter. So what reading we are getting, then that reading is called terminal potential difference of a cell. Okay. So when current flows through the circuit, there is fall of potential across. So when you choose on, so current will flow. Okay. There is a fall of potential across the internal resistance of the cell. The potential difference between the two poles of the cell is always less than the EMF, less than the EMF. Okay. So EMF is without using it, right? When we are not switching off, what is the potential difference? It is called EMF. So obviously EMF will be more because it is unused, right? Unused state of potential difference. So when we use it, that means we switch on, what reading? So the potential should drop, right, as soon as we switch on, because current is flowing. The potential difference of a cell is always less than its EMF, right? Okay.